Okay, hi everyone. We are just about at start time, so I think we're going to go ahead and get started. Before we get underway, one final warning: if you haven't got your environment set up, you can still take that red Post-it note, stick it on top of your laptop. One of us will come around and help you get set up. If you're ready to go, then great. I should actually take a second and explain these Post-it notes that you've all been given. You got a blue one and a red one. If you weren't here for when I mentioned it earlier, if everything's going okay, if your code is working, if things are fine, you're ready to continue, take that, take the blue Post-it note, pop it on top of your laptop, and that's how we will know that you're ready to go. If you need help with anything, if you need some instruction, if you're not sure where things have gone wrong, take the red Post-it note, stick it on top of your laptop, and that's how we'll know to come around and help you. If you have not yet filled out the sign-up sheet, please fill it out. We would really dig that. It'd be great. If you have filled it out, good job. All right, so that all in mind? Let me just give you a brief introduction to what we are doing. First off, my name is Bruce. I'm your instructor. I'll be guiding you through this adventure that we're all on. These workshops are hosted by the Ocean Tracking Network, or put on by the Ocean Tracking Network. And a big part of what we do is we connect researchers and scientists with people who put tags in fish. So people who are collecting data on fish movements, animal telemetry, bioacoustics, all kinds of great stuff. But you run into a problem when science and tech field work meet, in that a lot of times scientists don't know how to leverage code to process their data and make the most out of it, really derive a lot of the best insights from their data. So part of this workshop, part of the reason we're putting on this workshop is to give people a sense of some basic Python, some basic programming skills that are going to let you leverage your data to give you the best visualizations, insights, et cetera, et cetera. Even if you're not a biologist, this may prove useful in your field of study. Anywhere where you've got a lot of data that you need to do things with, in a general sense. That sounds vague, but really there is a lot that you can do once you know how to use Python to get into the guts of your data and mess around with it. All right. I'm seeing a lot of blue Post-it notes out there, so we will begin. We'll get underway with our lesson. All right. So by now, hopefully, you've seen and downloaded the data file that we sent around in an email to all of you. It's called surveys.csv. You should have received an email this morning from the Surge Workshop with the link in it to download. And you're going to want to make sure that that file is in the same root folder as your Jupyter Notebook instance. It's just for our purposes, it's just a test data set. If you want to know, it is from a long-term monitoring and experimental manipulation of a Chihuahuan desert ecosystem near Portal, Arizona, USA. Cool. For our purposes, it's some reasonably real-looking information that we can use to demonstrate how code works. The only other thing I will mention before we get started in earnest, a lot of this is going to build on lessons that we taught last term. We're starting a little bit into the lesson plan because we're building on that. If you weren't here last term, if you didn't make it to those workshops, it's, that's fine. There are a couple of lessons at the start of the curriculum, which you can get to from the event website. The first 2 lessons of the curriculum should get you up to speed. If you haven't already read through those, feel free to take a read through them if you're feeling a little lost. But yeah, we're going to be starting a little ways in with an assumption of some baseline knowledge. Missing anything? Cool. All right. Okay, so we've got the Jupyter Notebooks environment set up. We've got the survey data. The next logical question is, how do we get that data into Python, and how do we get it into a place where we can use it? So I'm going to open a new cell here, and I'm going to show you how to do that. If you don't know how I did what I did, if you press Shift and Enter in the cell of a Jupyter Notebook, that will run the code in that cell. But that cell just has Python comments in it, so there's not actually any code to run, so it just clicked over to the new cell. So how are we going to get that data into our code? We're going to use a library called Pandas. Pandas is not quite an acronym, but it's short for Python Data Analysis Library. It's a set of functions, code, subroutines that are all about managing and manipulating data in Python. You may have heard me use the word library just there. A library is just an external set of extra code that you can pull into your program. I'm going to show you how now. So if we want to use pandas in our Python program, we are going to type import. Import is a keyword. It tells us, or it tells Python rather, to import the following library, pandas. That tells Python to import pandas, to go get the library, download it, put it in the code, and make it accessible. We could leave it at that, but we're going to do one additional thing just to make our code a little cleaner, quicker, a little more readable. You can assign an imported library an alias or a nickname to make it quicker to type or to make it more descriptive, whatever you like. But we are going to type as PD. So import pandas as PD. I'm just going to make sure. Okay, good. Yeah, so what this means is that in the future, when we want to use a library from, or when we want to use a function from the pandas library, we're going to be able to refer to pandas as PD. And we'll see what that looks like in practice in just a moment. But for now, if we run this cell, there's no output, but we have imported the code. So great, we've got pandas, we're ready to get some data, start manipulating it. So the name of the data structure that pandas imports CSV data into is a data frame. What is a data frame? It's a two-dimensional data structure that can store data of different types, including characters, integers, floating point values, etc., etc. It structurally is similar to a two-dimensional array or a matrix, if you've seen that before. But it comes bundled with a lot of functionality right from pandas that lets you manipulate what's inside of it from a data management and analysis perspective. The way that we import CSV data into a pandas data frame is we're going to use a function called read CSV, which is inside of the pandas library. So the way we do that, I'm going to type this out and then I will explain it, but it's pd.read CSV and then surveys.csv. Now, I'm going to step through this and step through these wires. Oof. So PD refers to pandas. we've imported pandas as PD. So when we say PD, we mean pandas. Like I said, that alias makes it quicker to type. But aliases can be whatever you like. It doesn't have to be PD, although I have seen this convention a lot. I think it's quite normal. Read CSV is the name of the function. You've heard me say CSV a couple times now. If you're not familiar, it's just a file extension. It stands for comma separated values. Generally, it's used for large data sets that feature values separated by commas. It's pretty common. If you're going to be doing a lot of data analysis, you will probably run into a lot of CSVs. And then this, surveys.csv, is the name of the file that we want to load into our data structure. This is the path to the file for me. I've stored it in the root of my Jupyter Notebooks instance. We mentioned that that was how we were going to be running it. If you've got your file in a different place, you may run into problems. But if we run this code, aha! We get our data. Look at that. So we can see here that this is how Jupyter Notebooks prints a data frame. The CSV file has been pulled in, and it's interpreted in this tabular way. So for each record, we have a record ID, month, day, year, plot ID, referring to the plot in which the animal was collected, species ID, sex, hind foot length, and weight. So, cool. We have our data. How do we do something with it? It's the obvious next question. Oh, one other thing. Down at the bottom here, you can see that there's this break in the middle of all these ellipses. That's just, if we printed out all of the 35,549 rows, obviously that would be a lot to scan through. So often if you have large data sets, Jupyter Notebooks will truncate them, and that's what those ellipses mean. So you can see we jump right from record 29 to record 35,519. Right. How do we actually do something with this data? Well, the code that we just ran up here, pd.readcsv surveys.csv, that gives us this data, but it doesn't actually store it in our code. So we can't take this and do anything with it. This is obviously useful if all you want to do is look at a representative slice of the output, or of the CSV. But if we want to actually do something, we have to store that code in a variable. So to do that, we are going to type the name of the variable. I'm going to call it surveys_df. Let me see if I can scroll that up a little bit so that, can everybody see that? Is that cool right there? All right. Yeah, so I'm going to call my variable surveys_df, and then I'm going to say it equals, and then the same code as before, pd.read_csv and surveys.csv. Now if I run that code, you'll see that there's no output this time. That's because the result of pd.readcsv surveys.csv, rather than just being printed out to the window, is instead stored in this variable surveys.df. So if we just type surveys_df, we can see that's our that is our data frame, the same as we pulled it in before. All right. Before I move on, I want to just take a second and check in and ask, what questions do you have? Is there anything anybody would like to know? Anything unclear? Something that could be elaborated on? No? Cool. All right. Great. Okay. All right. So now we have our variable surveys_df. now that our data has been imported into a variable, we can actually do stuff with it, manipulate it, and view it. So we're going to go through a couple of functions now that are useful for displaying your data, seeing it presented in different forms. The first, and probably simplest, is a function called head. And I'll show you that now. If you type surveys underscore df, then dot head, like this, you can see that rather than trying to print all 35,549 rows, we just print the first 5, 0, 1, 2, 3, and 4. So that's what the head function does. It takes the first few rows of your data frame, and it just prints them to the terminal. So that's a useful thing to know if you just want to see like a little bit of your data. That can be a good way to do it. Another useful function to be aware of is called type, which I will show you here. If you say type surveys underscore df, we get this kind of, this is as far up as it'll go. Yep. If you type surveys.df, you get this kind of intimidating string of text, pandas.core.frame.dataframe. The reason you're seeing that is because that's the type of object that surveys df is. It's a data frame. Pandas core frame data frame. That's maybe not the most useful thing in the world. It would be neat if we could tell what's actually contained in what data types are contained in the survey's data frame. Fortunately, we can do that. Data frames have an attribute called dtypes, which I believe is short for data types. And if we take a look at that, which we can see by typing surveys underscore df dot dtypes, if we do that, that gives us the data types of all of our columns. So you can see that we had record ID, month, day, year, plot ID, etc. We can see that we have this 2-column output, one that lists the column name and one that lists the type of data that's stored in it. So these we can see are 64-bit integers. These ones are 64-bit floats, and these ones, species ID and sex, are objects. Yeah. And we can also see that the dtype, which I believe refers to the dtype of the data frame itself, is an object, because a data frame is a kind of object. So yeah, head and dtype, both useful ways to see what kind of data is stored in your data frame at a glance. A few minor notes about data frames. All of the data in a particular column is going to be of the same type. So everything in the month column is going to be an integer. Everything in the hindfoot length column is going to be a float. That's useful to know. The object type right there for species ID and sex, that's not super useful. It can refer to a lot of things. In this case, it's referring to strings. Species ID is a 2-character code, and sex is either M or F. We'll be talking more about data formats and in a different lesson later on down the line. For now, it's enough to know that in this specific case, those objects represent strings. So, how are we doing? Okay. There are a few more a few more functions and attributes that you can use to see what's contained in a data frame. Data frames have a lot of ways of displaying the data that's inside. You can use, for example, dot attribute, which will show you. Well, sorry, that's not quite correct. The syntax for accessing an attribute of the data frame is dot attribute name. So dtypes here is an attribute of this data frame. So it's not a function, so it isn't followed by the parentheses. So if what you're trying to access is a property of the data frame itself, you'd use this notation, dot attribute name. If you wanted to run a function on the data frame, like head, for example, head is a function that's contained within pandas. It's not an attribute of the data frame itself. So it has this function notation using those parentheses. Knowing that, I'm going to open up a brief exercise for you. Try using the following attributes and functions on your data frame and see what output you get. So we've got surveys underscore df columns, dot columns. We've got dot shape. We've got dot head parentheses. You've already seen that run, but it'll be useful to figure out what it does when you run it like this with a parameter inside those parentheses. And surveys underscore df dot tail, which is also a function. I'm going to give you guys a few minutes to try those out, see what kind of data they return, and then we will continue on. Okay. Everybody had a chance to give those a try, get a sense of what they print out. Okay. Sorry. Heard a weird noise and got freaked out. Right. So when it comes to these these two attributes and two functions, columns, shape, head, tail. Anybody want to elaborate on what one of these does? Now that you've all had a chance to see what they do, does anybody want to take a stab at what dot columns produces? Correct. Column names. If you type dot columns, surveys underscore df dot columns. Whoops. There we go. It produces your column names. Very useful to be able to spit that out at a glance. What about shape? Yeah.
It returns the number of rows followed by the number of columns.
That is correct. Number of rows followed by the number of columns. Surveys underscore df dot shape. Yep. You can see it prints out a parenthetically enclosed list, rows followed by columns. This is actually a data type called a tuple. We're going to get more into those later. Power cable. This fell on that. Right, yes. So we're going to get more into tuples later, but they too are very useful. Head we've covered. But how about head with a number in the brackets? Passing in a parameter. How does that modify the function? Sorry? Yep, exactly. It gives you that number of records. If we type out surveys underscore df dot head 15, nope, we could type 150. I'm not going to. It gives us the first 15 records instead of the first 5. Again, useful. And what about tail? Correct. It's the other end of head. It prints out the last few records of the list. Surveys underscore df dot tail. Yep. Much like head, it starts off with just the last 5. You will note, maybe, that the last record in the list is 35,548. You may remember that when we ran shape mere moments ago, it told us there were 35,549 rows. The reason for that, which may not be immediately apparent if you're not familiar with Python data structures, is that data frames are 0 indexed. So the records aren't counted from 1 to 35,549. They're counted from 0 to 35,548. Useful thing to be aware of. Okay, so this is all useful but a bit sleepy. Let's get into calculating statistics from data in one of these data frames. Before I jump into that, what are some of the questions you might have? Is there anything you want elaborated on, clarified? No? Excellent. Okay, so like I've been saying, Pandas contains a lot of functions for manipulating data with an eye to data analysis. And one of the ways that we can do that is, or one of the ways that we can interact with our data frames is to generate some statistics. So let's take a look at, well, some of the ways we can do that. First, we got to explore the data a little bit. So let's use that attribute that we used before, surveys underscore df dot columns. Let's get a list of the columns and find out what we're dealing with here. So we got record ID, month, day, year, etc. We've been through that. So let's suppose that we wanted to get a list of all of the species. Not just the column name itself, but just a list of all of the species that have been collected. If we want to do that, we can use a function in Pandas called unique. And that looks like this. PD dot unique, open parentheses, it's a function. Surveys underscore df, and then this is a new syntax here. Open square brackets and type species ID, which is the name of our column. So if we run that, we get this array here. I'll step you through some of the syntax just before we go on. Let me make sure I can. There we go. Okay, so PD we know refers to pandas. Dot unique is a function that returns only the unique entries in a list of data. So you can see each of these is only represented once in the list. So this has given us a unique list of the species that we're working with. This notation here, though, surveys underscore df species ID, that's data frame notation that lets you pull a specific column out of your data frame. So this right here, that won't give us the entire data frame. That'll just give us the species ID column. Which, yeah, if you're working with huge data sets, super useful to be able to just get one column. So I'm going to open things back up to you guys for a second. See if you can, using that, create a list of unique site IDs in the survey data, assigned to a variable called site names. And then let us know how many unique sites there are in the data, and how many unique species as well. And there's a follow-on question here. What's the difference between this function, underscore site names, and surveys underscore df, plot ID, and unique? I'll give you a few minutes to work through that. Again, if you run into any problems, if your code isn't working, we have the red Post-it notes that you can use to ask for help. All right. I think we've all had a chance to work that out. So let's check out this first question. Create a list of unique site IDs found in the survey's data. Call it site names. Anybody want to take a stab at answering this question? See any hands? No? 24 is correct. That is the number of unique sites. And the number of unique species. Oh, is it? Is that me? Okay. All right. Yeah, correct. There are 24 unique sites. Did anyone get a value for unique species? 49. Correct. Okay, good stuff. Let us go and generate that. We'll step through the code. So if we want to generate an array called site names of the unique site names, we call that array site names equals pd.unique. Oop, I should scroll up. No, that's as high as it'll go. I apologize. Soon it will become, soon it'll be more visible. pd.unique surveys underscore df and plot ID. And then if we print out len site names, that gives us 24. Correct. And yeah, if we do the same thing for species, we can actually just modify this. Now we'll create the new cell. So if we do the same thing with species IDs equals pd.unique surveys underscore df species ID, and then len species IDs, we get 49. So correct. So that's a quick way to see the number of unique elements in any given column. And moving on to this second question, which is a little more theoretical. Does anybody want to take a stab at outlining, even in a general sense, what the difference is between len, length, site names, and surveys df plot ID dot n unique? This one's a little more theoretical, so if you don't have a ready answer, it's cool. We're going to go through it together. Yeah?
So the first one, you're retrieving the length of the array that you generated, storing the unique site names, but then the second one, you're actually calling on your data and you're pulling out the number of unique ones, but they're not necessarily stored.
Correct. Yep, that is what's the answer I was thinking of. Which means it's right. No, there are other answers too, but that one is completely correct. This len site names is a way of measuring the length of the array. Site names, you've already created it, stored it in your code, and now you're measuring the length of it with this function that operates on an array. This second way of doing it, n unique, gives you the number of unique elements in a list, or in a data frame column, right? And yeah, this is calculating the same number, but it's doing it right from the data frame itself without having to create another array and store it in your memory. So yeah, there are different functions doing different things, but also the second one is a little less computationally intensive in terms of memory. So yeah. Anybody else have any further thoughts on the differences between those? Something else we might have missed? All right, cool. Well, I will, for the time being, I'll leave that as an exercise for just something to think about. Something to keep in the back of your brain as you go about the rest of your week. Yeah, little thing to take home with you. Okay, but back to statistics. One thing that Pandas lets you do with data frames that becomes very helpful in working with statistics and managing your data is creating groups. Panda has a function called group by. We'll get into it more later, but it does very much what it sounds like. It lets you group your data by certain parameters, by certain columns in this case. And we're going to step through how to use that and how to do a little more data exploration. Okay, good. So yeah, one thing that is super useful to be able to do is calculate the summary statistics of your data frame. There are lots of ways to do this. Pandas has built-in functions for maximum, minimum, mean, standard deviation. You can calculate them all individually. But even cooler than that, you can use a function called describe. So if we wanted to, for example, calculate the basic statistics of the weight column in our data frame, remembering, of course, that I will just type out surveys.df columns again. And yeah, so we have weight at the very end there. If we want to see the summary statistics for our weight column, we can do this. So surveys_df. We use that notation to access the weight column. And then dot describe. Open brackets, close brackets, because it's a function. And if we run that, we get all kinds of great summary statistics. We get the count, the number of weights in the column. We get the mean value, the standard deviation, the minimum, the maximum, and the values for the 25th, 50th, and 75th percentile. We also get the name of the column and the data type, float64, which we saw earlier when we printed out the data types of the data frame. So this is a super useful function that lets you see at a glance some of the core statistics of a column in your data set. And as I mentioned, we can also generate these metrics specifically. So if we wanted to, for example, just see the minimum, we could type surveys_df, access our weight column as such. And if we just want to see the minimum, we can type min. And that'll print out 4, which we can see is the minimum as given to us by describe. If we want to check out the maximum, we can do a similar thing. Surveys_df weight, and you can type maximum, or max rather. We do that, we get 280 as we got up here. So of these, we can generate count, mean, standard deviation, minimum, and maximum individually in this way, just by using functions like this. They are for count, it's .count. For mean, it's .mean. Standard deviation, .std, etc. So that's useful to be able to do. Those are good things to have. But we may want to summarize by one or more variables. And if we want to do that, we want to use group by. And once we've created a group by data frame, we can use that to very quickly generate summary statistics by a group of our choice. Before I jump into that, what are your questions? Anything that maybe could use a little more clarity, a little more info? No? Seems good. Okay, cool. Well, let's get into grouping some data then. It's fun. The way that we do this, for the next exercise, we're going to be grouping the data by the sex column. So the way that we're going to do that is we're going to make a new variable called grouped data, and we're going to say, we're going to set that equal to surveys df dot group by sex. So we do that. There's no output for this, but we have generated a new group by data frame, which is a specific kind of data frame that Pandas uses to hold grouped data. They're a little odd to work with sometimes, but once you've got the hang of it, it's very powerful. So describe, as we just learned, it'll return descriptive stats including the mean, the min, the max, the count for a particular column in the data. However, it'll only return summary values for columns containing numeric data. So if we say grouped data.describe, that's as high as that'll go, we get this kind of ugly looking thing. This can be a little hard to parse just at the start, but you can see over here our data is grouped by sex, so we have two rows, one for F, one for M. What we've done is we've taken all of the data in our data frame and grouped it by the sex column. So what you're seeing here is the record ID column, which is numeric, it's an integer. We have the count, the mean, the standard deviation, all of the summary statistics for the record ID column, which is a little weird and not necessarily super useful, but it's a useful illustration of you will get summary information on numeric columns regardless of whether or not they actually represent meaningful numbers. This does give you the count though, which that can be handy to have. But if we scroll sideways here, we can see that over here we have the same values for the weight column. And you'll recall I mentioned these ellipses mean that the data frame has been truncated. It's not showing us the whole spread of the data. We can in fact only see two full columns that we've summarized. But what's here is these summary statistics, count, mean, standard deviation, minimum, our percentiles, and max, for every single one of those columns in our group by data frame. So we've grouped all of the other columns by sex, so we would, if we could see the whole thing, we would see this kind of data laid out for all of our other columns: record ID, month, day, year, hind foot length, etc. We can see the very end of hind foot length right there. So a useful thing to be able to do, but yeah, the output can be a little difficult to parse at first. We also have the ability to run the summary statistic generating functions individually on the grouped data. For example, if we wanted to see the mean of all of our columns, we could type grouped data dot mean. This, of course, being a function that we run on the data frame. If we do that, this is a little easier to read. We have generated the mean for all of our numeric columns. Again, there's some in here that don't make a whole lot of sense. Record ID, there's not really a reason you would need the mean record ID, since it's not like a mathematical entity. The mean plot ID is also strange. Plot ID is represented as a number, so it's numeric. We get the mean. This is all a powerful object lesson in understanding your data and understanding what you're calculating. Oops, sorry. Nudged my mic there. Because yeah, depending on the data types that you get, functions may generate output that is not super useful. But we also have the mean hind foot length, the mean weight. We can imagine that being pretty useful. So yeah, the summary statistic functions can be generated or can be run individually as well as a part of describe on groups data in this way. That was a lot of kind of weird output, so I will just pause and ask, what are your questions? Anything not clear? Anything you'd like to understand a little better? Good? Okay, cool. All right, great. Okay, so yeah, the group by command, super powerful, super useful for allowing us to generate summary statistics very quickly based on a particular variable in our data set. And I'm going to give you guys an opportunity to witness that power firsthand with this quick challenge. So, using what you've learned, how many recorded individuals are female? How many are male? FM. What happens when you group by 2 columns using this syntax, we give it to you here, and then grab the mean values of that? And finally, and this one's a little more involved, summarize the weight values for each site in your data. And this little snippet of syntax will be useful here for when you need to only create summary statistics for one of the columns in your data. So we'll give you a few minutes to do that. Feel free to use the post-it notes if you need help getting started, or in the middle, or finishing, or at all. That's what they're for. And we'll come back in a couple of minutes and keep on rolling. Okay. Coming back to this challenge. All right. Who wants to take a stab at answering question 1? How many recorded individuals are female and how many male? Anybody want to take a shot at that? Yeah.
15,690 male and 17,348 male.
I believe that's correct. I don't have those numbers off the top of my head, but we can find out. Yep, there we go. Right up here in our group data describe, you can see we've got 15,690 female animals and 17,348 male animals. Correct. How about number 2? What happens when we run these 2 lines of code? We group by 2 variables, and then we take the mean of that. What sort of stuff do we see in there? Anybody want to take a shot at that? Yeah.
First it's grouped by plot ID, so all the unique plot IDs, and then it's also, there's a column for each, for male and male.
Yeah, exactly. We'll see real quick what that looks like here. If we do grouped data 2 equals surveys underscore df dot group by, and then we have to pass our list of columns in as an array. Otherwise, the group by function won't know what to do with it. But if we pass it plot ID and sex, run that, and we also run our grouped data 2 dot mean. That. Yeah, so it gives us first grouped by plot ID and then grouped by sex within that plot ID, and then it gives us the means of all our numeric columns as we did with our previous one. Okay, now for the big one. Anybody want to take a shot at 3, summarizing weight values for each site in your data? This one's a little trickier, so if you didn't...
Just one question to understand that. So data is a big data set, and each site, the sites are the plot ID, is the site labeled?
Yes, plot ID is the site. Make sure I've got my own. Yeah, okay.
That's a good clarification, though, that you have to know, like, if people ask you a real-world question about what your data is saying, you have to know what happened in the world maps to what your column names are.
Yeah, exactly. Yeah, good point. Okay. Let's just walk through this one right quick. Because, yeah, this one is a little, it's a little more conceptual. So if we want to generate summary data for the weight of each site, the first thing we need to do is group our data by site. So I'm going to start by hitting by site. By site, and that's going to equal surveys underscore df dot group by, and I'm going to type plot ID. And that gives us by site. So like we've been doing all along, I'm just taking our surveys data frame and grouping by plot ID, which will give us an object that contains all of our data grouped by site. So then, if I want to generate summary statistics for the weight column at each of my sites, the first thing I'm going to need to do is access the weight column. So we do that with that square bracket syntax, by site, weight. That'll give us the weight column from our grouped data set. And then I'm just going to hit describe. Type in describe. I keep saying hit. I don't know why. If I do that, you can see for each of our plot IDs, plot ID 1, 2, 3, 4, that tooltip out of there. There we go. For each of our plot IDs, we have the summary statistics for the weight column in each plot. So that's a pretty useful thing to be able to do. It's useful to be able to group your data by a particular variable, and then generate your summary statistics for your data at each of those plot sites. We could have done the same thing for each of the animal sexes. We could have done it on that large data frame of data grouped by both plot ID and sex. So that gives you a bit of a sense of some of the things you can do with pandas to interact with your data. Before I go on, is there anything else anybody would like clarified? What questions do you have just before we keep rolling? Cool? All right, cool. All right, great. So, another thing that's useful to be able to do is count the number of records, count the number of specific records inside of a Pandas data frame. For this, we're going to count the number of samples for each species. There are a few ways you can do this, but building on what we've learned, we're going to start by using group by, and then we're going to combine that with another method called count, another function called count. So the way we're going to do that is species counts. You can create a new variable. The species? Yeah. Species is one of those words I'm never quite sure I've spelled it right. So we're going to go surveys, data frame, dot, group by. We're going to group by species ID. Species ID. And then this is going to be a strange combination of syntaxes you've seen a few times before, so stick with me. We're going to open our square brackets and type in record ID, and then dot count. So I'll scroll this up a bit. So that, that's as high as it'll go. Okay. I'll step you through this code here, just for a second. Yeah, of course. Yeah. There we go. Yeah. That's better. Okay, so species counts equals, we're assigning a new variable called species counts. Surveys underscore df dot group by. We're taking our surveys data frame, grouping it by a particular variable. In this case, we're grouping it by species ID. Then we're going to access the record ID column of that result. So this code here, between my hands, is going to produce a group by object. And rather than assigning it to a variable and then accessing the variable's column from the variable name itself, we can actually just access the column right here before we've even assigned it to a variable. And that's useful if you're trying to save lines, save space, or if you know exactly what you're looking for. And then once we've done that, we're just going to add dot count to the end, and that will run the count function on the code that on the object we've created, the column in the object that we've created. And I'm just going to add under this print species count, and that'll display the number when we print it. Sorry? You should have let me fail. Then I would have had to explain myself. All right, so if we do that, you can see we get this large column of species IDs with their associated counts. So I don't know what these animals are, but we don't have that many of them. We got a lot of these guys. I don't know what animals these represent, but now I'm curious. Like I might dig into the data set after this and just like find out what we're dealing with. It'd be neat. But returning to the point, we can use this this method and these functions to generate the count of each of our species. We can also count just a specific species. I'll show you how to do that now. So if we say surveys underscore df dot group by species ID, we're grouping the data frame by the species ID. We're going to do the same thing that we did before, where we access our column right there in the, right from the group by. And we are once again going to type count. But that thing that we did where we where we perform our column index right with the group by, right from the results of the function, we're going to do that again here. And we are just going to count do. So again, this function count we've seen what it produces in this case. Because it's returning an object that we can index, we're just going to put our index right there. But this would be the same as if we took this code here, assigned it to a variable, and then if we called that variable count array or something, if we then did count array, square brackets, do to index it, we'd get the same result. But if I run this, you can see that we have 3,027 DOs, which if we go up here, you can see is right there in our count array as well. So how are we for time? We're rounding up on time. So okay, right. We'll continue with this next week. We'll cover some more of the some more functionality that you can use with data frames, some basic math functions, and we'll also get into some quick data visualization, which is always useful if you've got big data sets that you want to display to people. So yeah, we'll handle some plotting. Thanks everybody for coming. It was great to see you all here. Hope to see you again next week. Before you go, if you haven't hit the sign up sheet, sign it. But also, we would love if you could provide some feedback for us on your post-it notes. We would super appreciate if you could write one good thing, one thing that worked really well for you, one thing that you thought was great, something we can take to build on and do better in the future, and one thing that maybe didn't work so well, some constructive criticism on things we can improve on in future workshops. And then as you go out, stick those post-it notes to the door, and we will collect them and read them.
And I'm just going to say a few quick words before you leave. My name is Jordan. I'm the coordinator for Surge, which is where you currently are. If this is your first time, welcome. And if it's not, welcome back. Surge is Dalhousie's Science Innovation Sandbox. So we offer free programming, much like this, that helps with both your research and innovation. So you can find us at surgeinnovation.ca. And we have lots of free programming going on, some weekend events around specific topics, some things like this that are just kind of drop-in. One I'll mention to you folks, if you're interested, Friday we're doing a VR Ocean Challenge over at Shift Key Lab, which is in the Computer Science Building. We'll be getting into teams. They'll be coming up with some kind of idea using virtual or augmented reality to target a ocean problem. And then you have a chance to win. We're giving out Oculus VR headsets for the winning team, and then some Amazon gift cards for second and third place. So if that's something you're interested in, check out our website. It's up there. Again, sign in so that we can keep our metrics up to date, so we can get more funding to give cool workshops like this all the time. And that's all. Thanks, guys.
Right?
There's also more pizzas.
Yeah.
Yes.
Feel free to have some. But yeah, thanks for coming. Hope we see you again next week. Goodbye, stream.